and good morning to my lecturer and my friends. Let me introduce myself first. My name is Siti Nur Hatijah binti Ismail and my metric number is S30834. Today's topic is thermodynamic. What is thermodynamic? For your information, thermodynamic are combined from two different words. Is that thermo means heat and form of energy, while the dynamic is mean movement. Besides, thermodynamic is a branch of physics that deals with heat, work, temperature, and their relation to energy, radiation, and physical properties of matters. Process of transferring energy from one place to another and from one form to another. For example, the solid ice changes to the fluids and changes again to another stage like gases. Furthermore, in thermodynamics, absolutely we'll talk about heat and temperature. What is heat? Heat is a form of energy, can be conserved, transferred from one place to another, cannot be created or destroyed, and can be converted into the other form of energy. Moreover, temperature is measure of the heat between hot and coolness. The amount of heat depends on the speed and the number of atoms of molecules in motion. The faster of the atoms or molecules move, the higher the temperature, and the more atoms or molecules are in motion, the greater the quantity of the heat they transfer. For your information, temperature have three temperature scales. The first scale is also known as Celsius, but another name for Celsius is centigrade. Boiling point for the Celsius is 100 degrees Celsius, and the freezing point is 0 degrees Celsius. While the boiling point for Fahrenheit is contra with Celsius. Fahrenheit boiling point is 212 degrees Fahrenheit, and their freezing is 32 degrees Fahrenheit. The difference between boiling and freezing for Fahrenheit is 180 degrees Fahrenheit. And the last one is Kelvin. The last one is Kelvin. And the last one is Kelvin. These scales are very, very different with Celsius and Fahrenheit. This is scale absolute 0, and we need to add like 273 and 73.15 Celsius. Calculate the Kelvin temperature scales.
My name is Priscilla Hazelana George. Today I would like to present about objectives or learning outcomes of thermodynamics that we will learn today. Okay, firstly, we can describe the basic concepts of thermodynamics. Second, we will know how to calculate changes in kinetic, potential, enthalpy, and internal energy. Third, we can apply first law of thermodynamics for closed systems and construct conservations of mass and energy equations. Next, it also deals with study of energy, the conversions of energy between the different forms and the ability of energy to do work. Fifth, we will know how to state the first law and define heat, work, thermal efficiency, and the difference between various form of energy. And last, we can easily to identify and describe energy exchange processes in terms of various of energy, heat and work. And this is all of objectives or learning outcomes that we will get from learning thermodynamics. Uh, Actually, that's still a lot of objectives that we can get from learn of thermodynamics. That's all from me. Thank you.
Hi, my name is Maunaraka and I'm gonna talk about the first law of thermodynamics. The first law is about the law of conservation of energy. Conservation of energy principle to system where heat transfer and doing work are the methods of transferring energy into and out of the system. The work in internal energy of a system is equal the net heat transfer into the system minus the net work done by the system. So if we take a look at the small example here, an ideal gas in a cylinder with a movable piston. Assume that the piston has a cross-sectional area A. The gas expands by a small amount and the piston moves out by a small amount Y. The gas exerts a force F equal to PA on the piston and therefore does work W equal to Fy on the piston. So in thermodynamic process, we have four different gas processes. The first one, we have a diabatric process, isobaric process, isothermal process, isovolumetric process. Okay, so the first one is a diabatric process, a process which no heat enters or leaves the system. A physical property of the system depends only on the state of the system. There is two ways to prevent the transfer of the heat. The first one, we have provide very good thermal insulation of the system, and the second one, complete the process in a very short interval so there's no time for appreciable heat transfer. The second one, we have isobaric process. It occurs at the constant pressure. If the pressure of an ideal gas is constant, the temperature must increase when gas expands. Heat must be added during the expansion process. If the pressure is constant, the work done is pressure multiplied by the change in the volume. So the third one, we have isothermal process. The isothermal process occurs at the constant temperature. Since the internal energy of a gas only function of its temperature, expansion of an ideal gas is W equal to nRT. So the fourth, we have also known as isovolumetric process, or aka isochoric or isometric, takes place at constant volume. All the heat added to the system goes into increasing its internal energy. When the volume of a thermodynamic system is constant, it does zero work on the surroundings. So there is example here. Suppose there is a heat of 40 joule to a system, while the system does 10 joule of work. Later, there is heat transfer of 25 joule out of the system, while 4 joule of work is done on the system. What is the net change in internal energy of the system? So the first one, the net heat transfer is the heat transfer into the system minus the heat transfer out of the system. Q equal to 40 joule minus 25 joule equal to 15 joule. So the total work is the work done by the system minus the work done on the system. W equal to 10 joule minus 4 joule equal to 6 joule. C is use the formula, the first law of thermodynamics, which is Q minus W, same to 15 joule minus 6 joule equal to 9 joule. So the second example is, what is the change in internal energy of the system when a total 150 joule of heat transfer occurs out of the system and 159 joule of work is done on the system? So the A is the value of Q is already stated, which is 150 joule. B, the value of W is 159 joule. So we need to use the formula of the first law of thermodynamics, which is Q minus W will make 150 joule minus to 159 joule. We will get 9 joule. So that's all from me.
Hello, my name is Muhammad Alif bin Muhammad Idrus, matrix number S30885. Now, we have learned what is thermodynamics, and now we're going to go through application and discussion. So we have gone through on what is thermodynamics and its properties. But how does it apply in our daily life? How does it work on machines? Well, we cannot see energy with our naked eye. We also can touch them, but we can analyze them. There are three known heat transfers that we need to know in thermodynamics. First of all, it's convection. When a fluid, such as air or a liquid, is heated and then travels away from the source, it carries the thermal energy along. Thus, the meaning of convection. The fluid above a hot surface expands, becomes less dense, and rises. At the molecular level, the molecules expand upon introduction of thermal energy. As temperature of the given fluid mass increases, the volume of the fluid must increase by same factor. This effect on the fluid causes displacement. As the immediate hot air rises, it pushes denser, colder air down. For example, there are known two convections that we need to know. One of it is natural, another one is forced. The natural convection, for example, is hot air rises from the land on a warm day. For forced convection is the heating of an oven. Next up is conduction. Conduction transfer heat via direct molecular collision, an area of greater kinetic energy to transfer thermal energy to an area with lower kinetic energy. Higher speed particles will collide with slower speed particles. The slower the speed, it will increase in kinetic energy. As a result, conduction is the most common form of heat transfer and occurs via physical contact. For example, we will place our hand against a window or place metal into an open flame. The process of heat conduction depends on the following factors, um, as its temperature gradient, cross-section of the material, length of the travel path, and physical material properties. The temperature gradient is the physical quantity that describes the direction and rate of heat travel. Once there's thermal equilibrium between the two temperature differences, the thermal transfer stops. Now let's move on to radiation. Last but not least, thermal radiation generates from the emission of electromagnetic waves. These waves carry the energy away from the emitting object. For example, the sun is a clear example of heat radiation that transfers heat across the solar system. Radiation occurs through a vacuum or any transparent medium, either solid or fluid. Thermal radiation is the direct result of random movement of atoms and molecules in matter. Movement of the charged photons and electrons results in the emission of electromagnetic radiation. Some radiation is emitted in the form of visible light, but the heat component is in infrared rays. Now that we know the three heat transfers, now let's go on to the examples on what's happening throughout our daily life. Next up is oven. The oven uses the first law of thermodynamics. When an oven works, it uses the process of convection, which is the transfer of heat through fluids. The air is considered a fluid inside the oven because a fluid doesn't have to be liquid. When the air heats up, the hot air pushes the cold air out of the way, which creates an air current inside the oven, therefore heating by convection. This is done because when the air is heated, it becomes less dense than cold air, which causes it to rise while the cold air sinks. Next up is kitchen utensils. The pictures below are an example of a process of conduction. As you can see, it's boiling water inside a mug. That is the first law of thermodynamics. After a while, the heat from the water and the cup began to cool off slowly. Thus, it shows the second law of thermodynamics. This is when a hot object and a cold object combine, and then the heat object will transfer its heat energy to the cold object, which then it will occurs over time, and then it will reach thermal equilibrium. And then after it reach thermal equilibrium, it will stop giving off heat energy. Last but not least is the refrigerator. It is stated that a refrigerator seems to against the second law of thermodynamics. It is because if we look back, the second law of thermodynamics, it happens when a hot object goes through the process of work, and after a while, it becomes cold. But as you can see in the diagram, the cold part will receive input from work, and then will release heat. That's how refrigerator works. An open system that disperses heat from a closed space to a warmer area decreases in temperature, allowing food and other items to remain at a cool temperature. A refrigerator causes it to flow from cold to hot by imputing work, which cools the space inside the refrigerator. Manufacturer would want to make the area colder while doing as little work as possible. Stay at the desired temperature while using less electricity, therefore saving the owner money.
Hi, Assalamualaikum. I want to talk about acknowledgement about thermodynamic. We are really grateful because we managed to complete our SFP 1001 Introductory Physics assignment within the time given by our lecturer, Puan Fatihana binti Naning. This assignment cannot be complete without the effort, cooperation from our group members, Siti Nurhatijah, Priscilla Hazel, Muhammad Nur Hakam, and Muhammad Alif. We also sincerely thank our lecturer of SFP 1001 Introductory Physics, Puan Fatihana binti Naning, for the guidance and encouragement in finishing this assignment, and also for teaching us in this course. Last but not least, we would like to express our gratitude to our friends and respondents for the support and willingness to spend some time with us to fill in the questionnaires.